Hi, today I'm going to talk about big data, agile, and lean startup. So I'm the CTO of Databerries. At Databerries, we do marketing campaigns based on geolocation events to do drive to store. So everything is done on smartphones. So we will have, during the presentation, we'll have a quick refresher on Agile and startup methodologies, an overview of what it takes to build a big data architecture, the potential issues of mixing Agile, lean startup, and big data, my recommendation on how to address these issues, and a case study on the ingestion pipeline at Databerries. So the Agile Manifesto is composed of 12 principles. I took only 4 for this presentation. So we should have an early and continuous delivery of valuable software. We should harness change, the outside world change during your project. So we should address these changes. We should have a working software. We should release our working software frequently, about every few weeks for our startups. And we should have a simple software. I mean by simple software, not overly complex software if we don't need it. So the lean startup methodology, we have an ID. We build our software based on this ID. We released our software on the market. We get a feedback from the market, and then we have new IDs. The first loop is the product shipped, and the first loop is called an MVP, a minimum viable product, and the loop should take a few weeks. So this is a typical big data architecture. So it's an ingestion pipeline. So we have devices, servers to retrieve these events from the devices, a queue system. Here we have Kafka, a Spark streaming system to process these events, do machine learning, do cleaning also. And we have the storage parts, the storage layer in MongoDB, for example. And we have a monitoring system to understand what's going on our system in real time. I just wanted to tell you that it's complicated stuff, even to store some events in a database. So this is the involved technologies. Hadoop, Spark ML, Kafka, MongoDB, a visualization tool, a real-time monitoring system, and a centralized error management system. If you don't have these two last tools, you will lose some events at some point. So it takes about 6 months to build this kind of architecture. And as a startup, usually you don't have the time to do it. So I'm going to compare traditional database and big data database. So I took as an example Cassandra and MySQL. So everything on big data database are much more complicated. From the setup, the amount of knowledge required to build the MVP, the fine-tuning, which is mandatory for big data tools, the monitoring part, and the worst is the schema change. On a big data database, you design your database schema based on the queries that you would like to do. So if you want to evolve or doing some evolution on your products and you have new queries, usually you have to change the schema. And you have no tools to do the migration. So you have to export everything, run a script on all your data, and re-import all your data in a new database. On MySQL, it's much more different. with a correctly designed schema, you can run any queries that you want. If you compare Agile and Lean methodologies and big data technologies, it's very hard to build an MVP with some big data tech. The feedback loop, the Lean startup loop is really long, and we have a complex software from the beginning. So Agile Lean methodologies do not seem to be compatible with big data technologies. My recommendation will be to stay on small data technologies as much as you can. You can run, for example, your MVP on a small part of your data and take only the most valuable part of this data. The trick is to do the filtering as early as possible in your process. You can do, for example, a filtering on your data source. If you are using Twitter, for example, if you are using Twitter as your data source, you can provide them the filter and they will only send you the data that you are interested in. If you can't do that, just do the filtering as early as possible in your system. So at Databerries, we collect geolocation events from smartphones. Then we store them, we analyze them, we run campaign advertising based on this geolocation data. And we measure the impact of the advertising campaign in store. So we are going to focus only on the ingestion pipeline. So on the MVP, we built SDKs to collect events from partner applications. We deployed a server application on App Engine in Python Django, because Python is quick to write, and App Engine requires no infrastructure management. And we used Google Cloud Data Store as a storage layer. When the SDK was live in our first partner application, we had performance issues with the data store. The backups right now were not working well also, but we had many data points from outside France. We had only 10%, 90% of the data outside France for our first partner application. So we decided to reduce the load by applying a filter to keep only French events. Then we had more and more SDKs integration in partner apps. We had to migrate from App Engine, which was too costly, to a Google Compute Engine machine. It's like Amazon EC2, but on a Google platform. And we chose Docker to ease the deployment. So we had our SDK, Python Django application inside Docker, running on a regular VM, and we chose also to replace the data store by Google BigQuery. We had issues with Docker because it was not mature. Logs were not working well, and it was not stable under high load. So we moved out of Docker. It was a mistake to use Docker because we did not really needed it at this time. Then we had more and more data. We decided to refactor the architecture, and we replaced Python with Java, which is a bit more powerful, and with Vertex, which is a non-blocking I/O framework. It's you use this kind of framework when you want high performance. We decided that we needed to batch our events to BigQuery, so we implemented RabbitMQ, which is just a message queue system. It's a regular one, it's not a big data one, like Kafka. RabbitMQ did not handle the load. We did some fine-tuning to reach up to 50,000 messages per second on the JSON pipeline, which is okay. And it's only recently that RabbitMQ was not keeping up. So we migrated to Kafka to reach up to 200,000 messages per second. And during the migration, we noticed that we were lucky to have not migrated earlier because we needed some features which were only available in the last version of Kafka. So what we did well, we had an MVP very quickly. We learned how to store a high amount of data progressively. We did not migrate to Kafka too early, and we migrate to Java and Vertex at the right time. However, what we did wrong is that we migrated to big data technologies a bit too early. And what we should have done is to filter much more the data. We filter the data from worldwide to France, but at the beginning we had only a few customers, so we could have filtered the data only to a few places in France to divide the load by at least 100. It would have let us to focus on other parts of the platform. So conclusion, I would recommend to filter heavily your data to be able to release an MVP very quickly. Avoid the hype of new tools if you don't need them. We migrated only very lately to Kafka, and we made the mistake of using Docker at the beginning only because it was hype. And migrate, you can always migrate to big data technologies progressively. If you are microservice oriented, you can always replace components.